Hello, chemical systems. So today you were learning about dissolving rates or solubility factors. So these are factors that makes a different kind of solutes dissolve faster or slower. So recently we've been talking about solubility of salts, but now we're going to talk about different things. We're just going to talk about how things dissolve in water. And this is important. We'll get to why it's important a little bit later. Lots of different reasons this is important. But I have some hot water here, so my time to kind of tick in. So let me just kind of talk about the experiment I'm going to do. So what I have here in these 2 cups, I have brown sugar right here. My brown sugar has gotten pretty hard because I don't use it that much. So let me get closer to the camera so you can see it. After I trip over the trash can. So in 1 cup, I have 3 big chunks of brown sugar. And then I have some brown sugar that I made sure is nice and fine, both 12 grams. I know that they're both 12 grams of sugar because I weighed it, the kitchen scale. I hear that these are amazing for cooking. Strangely enough, I don't use it for cooking. I use it for experiments like these. So I have hot water here because I've used cold water. If you read the CK12 chapter today, you'll know that the warmer temperature is, the faster it will dissolve. So since this is a video, I'm going to just kind of shorten the time a little bit and start with some hot tap water. We're assuming that these are both at the same temperature because I fill them at the same time. So I'm making a few assumptions here. Roughly the same amounts of water, same amounts of sugar. The only difference is that I have clumps of brown sugar and fine brown sugar. And if you cook with brown sugar, you know that it's really easy for brown sugar to come in lumps, get hard. So let me make sure my timer is ready here. What I'm going to do is I'm going to time this. I'm going to see which one dissolves faster. So I'm going to press start as soon as these are both dumped in there. And you can almost immediately see that this one dissolved much quicker. Just by looking at the color. I think I'm gonna bring it closer to the camera because it might look to you like, well, it looks like they're both kind of settled at the bottom. But if you look at the color, maybe it's not as easy to see on camera, but see how clear the wall. This is the one that had the solid chunks of brown sugar. And this is the one that had the fine brown sugar. So even though it's held to the bottom, you can see that this one has a slight caramel discoloration to it. Not so with this one. I think I'm gonna set the timer, take the timer off for this one, because I don't think we're gonna see any more dissolving here without me stirring. And stirring wasn't part of the experiment. You guys will read about how stirring can affect solubility. So I'm just gonna go on and go ahead to the next experiment. All right, here's part 2 of the experiment. So this time I'm doing the same idea, except I'm using medicine. So hopefully now you can see why solubility might be important when it comes to how things dissolve, because medicine is a solid that we dissolve in our bodies. Well, I shouldn't say medicine, not all medicines are solid, some of them are liquid. Some might be gas actually. But anyway, either way, they dissolve into our bloodstream. And so the time it takes to dissolve in our stomach or in our blood is really important. And pharmacists determine how the medicine should be delivered by how long it takes to dissolve and how long that medicine will take to get to this specified target in the body. So there's a whole science, devoted to just drug development. And solubility is an important factor. So to study this or to do an experiment on this, I have 2 types of medicine: antacid, or the generic version of Tums. I have 2 solid tablets here that are red, and then I have 2 purple ones that I've dissolved into a powder. And then I'm doing the same thing with ibuprofen, Advil. I have 4 solid tablets here and 4 solid tablets that are broken up. I basically just smashed them. Now I kind of cheated when it came to the unsmashed version of ibuprofen because normally these kind of pills come with a waxy coating. See if you can see it here. I took that waxy coating off because that waxy coating gives it a little bit of waterproof, and I didn't want it to be exactly waterproof. I wanted to stand some fighting chance, because what we're trying to show here is if you have something in powdered form, how more quickly it should dissolve. Because so according to if our last experiment was right, the medicines that are already broken up should dissolve much more quickly. I'll talk about that at the end here. So I'll start with the antacid. Just go a little quickly. Again, I'm using warm water to get the experiment to go a little bit faster. Not the result I expected. The antacid in the dissolved form kind of clumped up and made this weird sculpture. And now I'm really curious to know why the heck that is. But anyway, you can see that some has already dissolved on top. I'm just going to give this a quick stir. I said I wasn't going to, but just to see if I can kind of force either one of these. So stirring the ones that are tablets didn't seem to do much, but let's stir the ones that were pre-dissolved. And it doesn't take much to see that. Yeah, it's already getting cloudy. It's already dissolving pretty quickly. Okay. That is really interesting. I don't know why that happened. It made kind of like a statue in there. Okay, anyway, so ibuprofen. There we go. Yeah, there we go. So here's the ones I smashed up, and here's the pills that I didn't smash up. So I don't want you to think that, oh, well, that's why my headaches aren't cured, because I don't smash up my medicine before I take it. Well, your stomach is much different than what's going on inside these glasses because you have stomach acid. That stomach acid helps dissolve things a lot more quickly. So since you have acid in your stomach, you have a higher pH. Solutions with a higher pH tend to dissolve certain substances a little bit better. But even without having to dissolve them, you can, even without smashing the pills, it still is dissolving. Just a lot more slowly. Whereas the ones I already smashed up, probably one good stir and this would be completely dissolved in the water. Okay, so what's the point of these experiments? So CK12 gave you talked about lots of different things. It talked about how does temperature affect solubility, how does stirring affect solubility, and how does surface area affect solubility. So we did not experiment on temperature or stirring. We did experiment on surface area. So what do I mean by surface area? Well, let's just take these antacid tablets here. Okay, so when I say surface area, that's how much space is on the outside of these tablets. If I break one in half, I've already increased the surface area a little bit because now there's this extra area. If I keep on breaking these down to smaller and smaller particles, well, then I have a ton of surface area. So the more area that these individual particles are exposed to water, the faster it will dissolve, which will make sense because a whole tablet, water has to dissolve layer after layer after layer until it can get down to dissolve the very last particle on the inside of this tablet. Whereas with something like this, surface area is much greater, so it dissolves much quicker. Some medicines are even gels. Now, this is not medicine. I wish I had some gel medicine to show you, but if you can just imagine that this is a Advil gel, they dissolve very quickly. And you can just see how that food coloring spreads throughout the liquid. The medicines or gel will do something very similar. Anyway, so what I'm showing you is that when you have a solute with a higher surface area, a solid with a higher surface area, it dissolves much quicker. So if you're trying to dissolve something in the kitchen or for whatever reason, and you can't get that substance dissolve, just try smashing it up before you put it in the liquid. So that's the end of this video. I'm gonna have some questions to go with this, so please scroll down, answer the questions. I'll talk to you later. Bye-bye.